Okay, we'll continue with number 75 here. Here we have the limit as t approaches 0 of sine of 3t over 2t. Now we can bring out the 2 from the 2t so that we get 1/2 of the limit as t approaches 0 of sine of 3t over t. And this is not quite what we have above. We're looking for sine of t over t. But what we can do to compensate for that is to multiply the top and bottom by 3. And when we do that, we're going to take the 3 on the top and bring it out through the limit so that we get 3 over 2. And so we get limit as t approaches 0 of 3/2, and actually the 3/2 should come outside the limit, so that we get 3/2 limit as t approaches 0 of sine of 3t over t. And as t goes to 0, 3t also goes to 0, and what you're going to have is that same limit. Now this is explained in a number of different ways, but I'll just try to put it in as simple terms as possible. As long as we have the limit as t approaches 0 of sine of 3t over 3t, then that is basically the same idea as sine of t over t. Some people have explained it this way. If we let u equals 3t, then we have 3/2 the limit as u approaches 0 of sine of u over u, and that just becomes 1. And as 3t goes to 0, you should be able to see, or as t goes to 0, u, or 3t, goes to 0. And so what we end up here with is just 3/2. Now some people would look at that and see, well, it's just the 3 over the 2 inside the sine expression, but we really can't factor that 3 out. Everybody should remember, when you have sine of 3t, you just can't factor the 3 out. That does not equal 3 times the sine of t. But if we get sine of 3t over 3t, then we can use the limit as t approaches 0 to find our answer. We'll try to get in number 76 as well. Now, number 76 uses the same type of reasoning. We have the limit as x approaches 0 of sine of 2x over sine of 3x. And what I want to do first is to get it in the form of sine x over x. That's the target that I'm trying to aim for. I'm going to first divide the top and bottom by x. So I'd have the limit as x approaches 0 of sine of 2x over x over sine of 3x over x. Now we're still not quite there yet. We still need to get a 2x in the denominator in the numerator, but the only way we can do that is by multiplying top and bottom by 2. And I still need a 3x in the denominator, but the only way I can do that is by multiplying top and bottom by 3. And so now we have the sine of 2x over 2x in the numerator, and that's just 1, multiplied by the 2 that's out there already. And we have sine of 3x over 3x in the denominator, and that's just 1, multiplied by the 3 that's there already. And so this just comes out to be 2/3, sorry. And again, it appears to be just the 2 over the 3 there, but the answer is a lot more complicated than that. But that is essentially, if you see that, then that will be the answer of 2/3 there. Alright, so that does it for evaluating limits algebraically using trigonometric functions. It's all based on those 3 ideas that you see above, and you should try the other problems, 66 through 74 anyway, the even problems, and they may require slightly different types of strategies, skills, techniques, but the basic idea is the same. You're trying to identify those 3 big forms and to work with them accordingly. That'll do it for this. We'll go on to problem 77.